All right, today we are looking at review 1.1c, multiplying and dividing integers, as well as multiplying and dividing a few fractions here and there, as that's the easy part of working with fractions. So this will be the third part of our review and the third and final part before we go ahead and start to get into the new material for the chapter. So after this, we're into doing some actual algebra, so I'm sure you're all looking forward to that. So we're going to begin with working on our multiplying and dividing integers. And I'm sure all of you remember what an integer are, as we learned that in 1.1a. And we're going to begin with same sign multiplication. And also same sign division. So our first example is a classic, 3 times 9. And I just realized I really need to move this over so you can actually see the whole thing. There we go, much better. Same sign multiplication. Now, if you're a little bit rusty on your multiplication, you can also think of it as being repeated addition. 3 times 9 can also be thought of as being 9 plus 9 plus 9, 9 added to itself 3 times. Regardless of which one you choose to use, 3 times 9 ultimately ends up being 27. By the same token, however, because the same sign results in positive 27 as we have here, we have the same sign when we have negative 3 times negative 9, which can either be represented by two sets of parentheses sitting next to each other, or you can have the multiplication sign between them, the dot that I used before. Regardless, when we do the multiplication of two negative numbers, the answer always also ends up being positive. And it is of the same amount as 3 times 9 is. It's 27. The negative times the negative always makes a positive. So when we have a same sign when we're doing multiplication and division, and this is the important conclusion that we're able to draw from this section, our same sign always results in positive numbers. If we look at division, you'll find that it also behaves in exactly the same way. 32 divided by 8, for example, you think about how many times it takes to add 8 to itself in order to get to 32. 8 plus 8 is 16. 16 plus 8 is 24. That's 3 times. And then 24 plus 8 makes 32, 4 times, which means that 32 divided by 8 is 4. If we were to do the same thing using negative numbers, negative 32 divided by negative 8, the negatives once again cancel each other out, and our answer is always going to be positive. And since the numbers 32 and 8 are unchanged, our solution will once again be positive 4. So, if we go ahead and look at what we've seen so far, and we were to put this into some rules, plus times plus equals plus. Minus times minus equals plus. Plus divided by plus is also a plus, and minus divided by minus is also a plus. So anytime the signs match, the result is always positive. And you must be careful on this because you might get it confused with subtraction and addition, because that behaves in a slightly different way than multiplication and division is. Because I don't want to see you doing negative 3 minus 9 is positive 12. That's negative 12. It's only with the multiplication and division, the signs match, makes always positive. Now, let's go ahead and look at what happens when we have different signs. And I imagine many of you are quite clever and are already able to recognize what's going to happen when we have different signs. And we'll begin by looking at 3 times negative 9. Now you know that 3 times 9 is already 27. But the rule with multiplication, when we have opposite signs, or conflicting signs, where one is positive and one is negative, the result is that our answer will always be negative. Likewise, if we were to take a look at negative 3 times a positive 9, that is also negative 27. So 3 times negative 9 and negative 3 times 9 both equal negative 27. There can only be one negative sign. Otherwise, the pair of negative signs will cancel each other out and result in a positive, which is what we saw in these two problems earlier. Likewise, if we look at division, division behaves exactly the same way. So we begin with negative 32 divided by 8. 32 divided by 8 is still 4, but since one of our numbers is negative and the other is positive, our answer is negative. Likewise, if we flip the negative sign to the bottom of our fraction, or into the divisor, 32 divided by negative 8 is again going to be negative 4. Now, let's go ahead and look at our always negative rules. So when the signs are different, it is always negative. Although we'll learn exactly what that means in another and rather more complicated example problem. So, if we have plus times minus, that gives us a minus. We have minus times plus, that gives us a minus. We have minus divided by plus, that also gives us a minus. And we have plus divided by minus, that still gives us a minus. Also, note that every time I say minus, I also mean negative. Okay, well, let's go ahead and take a look at a quick example, and you might want to pause the video so you can think about how this one is going to work, because I'm just going to keep going. Let's move our piece of paper up a little bit. On this one, we're actually going to have multiple numbers involved. Negative 6 times 2 divided by a negative 4. And you're going to have to reach way back into your head and remember the order of operations: PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. And on this one, we need to, since it's all multiplication and division, we just need to do it in order from left to right. So the first part is we need to take negative 6 times 2. Since this is a negative times a positive, we know our answer has different signs, so it'll be negative. 6 times 2 is 12, so it is a negative 12. Then we need to divide our negative 12 by our negative 4. Now, since we have two negative numbers, a negative divided by a negative is a positive, and you need only check what 12 divided by 4 is, and that is 3. So on this one, we had two negatives and a positive. The two negatives, each pair of negatives will cancel each other out, and it's important that you make sure that when you go through one of these problems, you go step by step and make sure that at each point that you do an operation, you resolve and check to see, all right, did the negative sign make it to the end here? All right, the last part of this video is we're going to take a look at multiplying and dividing fractions. Now this is as much of a warning as it is anything else. The assignment won't have any fractions on it, but it's pretty quick and easy to go through multiplying and dividing fractions, so I figure we would talk about it today. Because for the most part, it's just multiplying and dividing integers again. So when you multiply fractions, let's give an example of 3 divided by 4 times negative 1 divided by 6. The thing that makes this work so great is when you multiply fractions, you literally just multiply across. So you multiply the 3 times the negative 1 and the 4 times 6. So our rule for fractions is multiply across. Three times negative 1 gives us negative 3, and 4 times 6 gives us 24. From here, we're actually able to reduce this fraction. We're able to reduce numbers which have the same common factor between them. So 3 goes into 3, and 3 also goes into 24. So we're able to say that negative 3 divided by 3 gives us negative 1, and 24 divided by 3 gives us 8, and a final correct answer of negative 1/8. we are also going to take a quick look at dividing fractions. And the reason we're going to look at dividing fractions is because dividing fractions is actually just multiplying fractions. So, for our dividing fractions example, we're going to have negative 7 divided by 2 divided by 3/10, or 3 over 10. And the reason why I said that this is essentially the same as multiplication is because the step you actually take is the negative 7/2 remains the same. However, instead of dividing by 3/10, we actually multiply by the inverse of the second fraction. In this case, the second fraction was previously 3 divided by 10. It's now 10 divided by 3. And once you do this, these two statements equal each other. So after you do the division here, or the multiplication here, you'll end up getting your answer, assuming you correctly reduce everything. So once again, we need to multiply across. 7 goes to the 10, the 2 goes to the 3. This gives us negative 70 divided by 6. From here, we're actually able to reduce our fraction a little bit because both of these are even numbers. We can divide both of them by 2. 70 divided by 2, half of 70 is 35. The negative sign carries along because that was a negative and a positive. And on the bottom, 6 divided by 2 is 3, getting us to our final answer. So our rule when doing division is flip fraction 2 and multiply. As I struggle to get this all on the page. So, when dividing fractions, super easy. Just flip the second fraction and then turn it into a multiplication problem and proceed as you would when multiplying fractions where you just multiply across. Now adding and subtracting fractions is a little bit more complicated, and I'm sure we'll go over that another time. But for now, multiplying fractions is pretty much as easy as doing integer multiplication and integer division.